Math 3, Unit 8, Section 3, continued. So yesterday we talked about this once I stopped the recording, but you should have negative values here based on that we're going to the left, which is a negative 1/2, and we're going down, which is a negative root 3 over 2. So you want to pay attention to that. So over here for sine of 60 degrees, it should have been negative root 3 over 2. Cosine should be negative 1/2, and then on tangent, it's a negative divided by a negative, which ends up making a positive. Okay, next problem. So this time we have 405 degrees. First thing is that all circles have how many degrees? 360. So we know for sure we're going to do one whole loop around, and then how do we figure out how much further we go? 405 minus 360, and we subtract, and we end up getting 45. So which quadrant will we end up in? Quadrant 1. Very good. Now, when we mark this, we will still mark this as 405 degrees, because that's how far we're going. Okay? We know it's in quadrant 1. But our reference angle, you just told me what my reference angle was, and it was this distance from here to here, which happens to be how much? 45 degrees. So my reference angle, 45 degrees. So we're going to go ahead and draw our triangle. Now, do you guys want me to pull the triangle out and look at it bigger, or is it okay looking at it right here? There's fine. Okay, so we have a 45, 45, 90 triangle. And so if we go up here to the work that we did, across from each of the 45 sides is what? Good. Root 2, and because we ended up rationalizing the denominator, and so on each of the sides it's going to be root 2 over 2. Everybody good with that? Okay. So each of my 45 sides is root 2 over 2. And we know that our hypotenuse, or the radius, there is 1. We are finding sine of 45 degrees for each of these triangles. Or sorry, 45 degrees is the angle for each of those. Do I have to worry about negative signs on this one at all? Nope, because it's going right, which is positive, and it's going up, which is positive. Okay, again, remember that our value for sine is y. Our value for cosine is x, and then tangent is y over x. And so what is my y value? Good. And then cosine is root 2 over 2. And for tangent, we know that the denominators, which are 2, will end up canceling out when we do our same change flip stuff. And so really, tangent is root 2 over root 2. You are just taking the numerators. So you're taking the root 2 over root 2, and that ends up reducing to be what? 1. That's it. Any questions? Yes, that's how it is originally. And so yesterday, when we were going through this, see how it originally had a root 2 and a 1 and a 1? Well, because on our unit circle, the hypotenuse or radius needs to be 1. And so we talked through how root 2, in order to make a root 2 1, we would divide by root 2, which makes it 1. But since I'm dividing by root 2 here, we have to divide it to everything within that triangle. And so this just makes it more helpful so that we're not having to rationalize the denominators each time if we have it this way. Does that make sense? Okay. Any other questions? Okay, so 330 degrees. Which quadrant will we end up in? Very good. Okay, so we have quadrant 4. And we're going to go ahead and draw this. And it ends here. Label it 330 degrees. And I want you guys to go ahead and find your reference angle and try to set up that triangle. But we'll talk through it. I just want to give you about 30 seconds or so to try to set that one up. So what's the reference angle? Good. So whatever your reference angle is, that's what you're taking sine, cosine, and tangent of, okay? Now, if this is 30 degrees right here, we go back to our triangle that we made up here. And so we have our 30, 60, 90 triangle, okay? So across from the 30 is 1/2, and across from the 60 is √3/2, okay? So across from the 30 is that line right there. So you should have written this as 1/2 there. And then this is, if this is 30, this was our 60, and across from the 60 is √3/2. And then we just need to think about positives and negatives. So going to the right for our x value, √3/2, that would be positive or negative? Positive. But then going down here, that would be, so that should be a -1/2. How many of you got that right? Good. Okay, does anybody have questions? If you didn't get it, maybe you just didn't have enough time. Do we have questions about it? No? Okay, so now we can figure out sine, cosine, and tangent based on everything that we have there. So again, sine is dealing with our y value, cosine is x, and tangent is y/x. Okay, so my y value in this case is -1/2. My x value is √3/2. And then for tangent, what? Oh, thank you. Okay, and tangent, again, we're going to do y/x. How would I write that? Very good. -1/√3. Is that an okay answer? No, why not? Root in the denominator. So we need to rationalize the denominator, and we do that by? Very good. So in the denominator, the 2 √3's will end up giving us a 3, and then on the top we have -√3. And remember the negative, it doesn't matter if it's with the top or the bottom, it's just that that number is negative, where if we had 2 negatives, it makes a positive, and so on. Okay, any questions? We're good? Okay, I'm going to turn the page. We're good? All right. Okay, so this next part says to sketch each angle in standard position and identify the sine, cosine, and tangent ratio for each. Now, what you'll notice on this is -90 degrees. It's right on one of our lines. Okay, so -90 degrees goes right here. Do you guys agree? So I'm going to make a point there, and I'm going to write -90 degrees. Remember that we are dealing with a unit circle. So that means that this distance right here is what distance? All of the radius on the circle is what? 1. Do you guys agree this distance here is 1? So when you're going to -90 degrees, this point here, this distance is 1, but in terms of an ordered pair, what would that be? What would this point be? Is it going any direction on the x-axis? 0, -1 would be correct. And good, because you notice that you're going down, so it's at 0, -1. Okay, are we all, does that make sense? Now, in terms of sine, cosine, and tangent, remember that these are x and y values. We know that sine is dealing with the y, cosine is dealing with the x, and tangent is y/x. So what is sine? -1. What is cosine? 0. And then y/x would be -1/0, but can you ever have a 0 in the denominator? No, it's undefined. So this one for tangent is actually no solution. Okay. So based on what I just told you, we're going to do one more together, and then you're going to do the next one on your own after that. Okay, we have 180 degrees. This is a positive, so we're going to go counterclockwise. Okay, and so we start at our initial side, and we go around, and we end up here. Okay, again, our radius on all of this is always 1. So therefore, what is the ordered pair here at 180 degrees? Negative 1, 0 is correct. And then I would label these as x and y so I don't mess anything up. Our sine value is always the y, cosine is x, tangent is y over x. What is my y value? 0. What is my x value? Negative 1. And then y over x is 0 over negative 1, which is actually equal to 0. So if you have 0 on the top, it's just 0. 0 under is undefined. All right, any questions on that one? Okay, I'm going to give you about 30 seconds or so to try the next one on your own. Okay, so 360 degrees, you start at your initial side, it wraps around, and it ends right back at your initial side. What is your ordered pair here? 0. Very good. Label it with your x and y. We know that sine is y, cosine is x, and tangent is y over x. What is sine? 0. Cosine is 1, and 0 over 1 equals 0. All right, last one, negative 270 degrees. So negative means we're going to go which direction? Down or down or clockwise. And so negative 270 degrees, we know that each one is 90, right? So that's 90, that's negative 180. So negative 270 would be up here. And I forgot we should be labeling that. So that's negative 270 degrees. Over here, this was 360 degrees. Okay. All right, so what is my ordered pair at negative 270 degrees?
0, 1.
Very good. 0, 1 is correct. Label with x and y. Again, I'd label these every time. So sine is y, cosine is x, tangent is y over x. So my sine value for this problem is 1, cosine is 0, and tangent would be 1 over 0, which is actually undefined or no solution. Any questions? Okay. So this next part states, identify all the quadrants where the terminating ray for theta can lie so that the equation will be true. Hint, there should be at least 2 quadrants identified for each of these. Okay. So first of all, here they are telling us that cosine is negative. Okay? We know that cosine is dealing with which value? Cosine is dealing with the x value. Would everybody agree with that? Yes? Okay. So, if we are looking at our, my mind is going blank, our graph, our coordinate plane. Oh my goodness. Okay. This is our x-axis, this is our y-axis, correct? Okay, so in this quadrant right here, the x values are what? Positive or negative? Positive, okay? In quadrant 2, the x values are positive or negative? Negative. Because in order to get into this quadrant, you would go negative on the x-axis. Your x values would be negative here. Okay? In quadrant 3, the x values are what? Negative. And then in quadrant 4, the x values are positive. And so what two quadrants could this answer be in? 2 and 3. Okay? So that's all this is. The answer is quadrant 2 and quadrant 3. That is where you could get this answer. Okay, this next one is talking about sine, and it's saying where is sine possibly positive 2 over 5 or negative 2 over 5? Well, we know sine is dealing with the y value. And what it's saying is that sine could be positive or negative. Do you guys think you know what the answer is? It's all of them. That's right. But let's just go through and talk about sine really quick. So sine is dealing with your y values. And so in quadrant 1, the y values are positive or negative? Positive. Because here's your y-axis. You're going up, which is positive. In quadrant 2, the y values are positive. In quadrant 3, the sine values or y values are negative. In quadrant 4, the sine values are negative. And so this answer is quadrant 1, quadrant 2, quadrant 3, quadrant 4. If you put all 4, that's fine. I'm just writing it out. Okay. Now, tangent is dealing with y divided by x. Okay. So this one is a little bit more tricky. Okay, again, I'm just going to label this x and y. So in this quadrant, so each of these, I'm going to write here y divided by x, in all of my quadrants so we can like visually see what's happening. In quadrant 1, y is what? Positive, and x is positive, which means that tangent is positive. Okay, so my y value is positive, my x value is positive, therefore tangent's positive. Okay, in quadrant 2, the y value is what? Positive, and the x value is negative, and a positive divided by a negative is a negative. Did I hear somebody say I don't get it? Okay, here is your x-axis, correct? So going to the left on your x-axis gives you a negative value. All values to the left on the x-axis are negative. All values to the right on the x-axis are positive. If you're dealing with the y-axis, and maybe I should label this here, but so going to the right on the x-axis is positive, going to the left is negative. On the y-axis, going up is positive, going down is negative. And so in this quadrant right here, the y value is positive and the x value is negative. Is that better? Because I was explaining it for you, Riley, and it was like you weren't even listening to what I was saying. Oh, you did understand it? Oh, I'm sorry. I thought you said you did not. Okay. So, y in this quadrant is what? Negative. And the x value is negative. And what is a negative divided by a negative? A positive. Okay, this last one right here, the y value is what? Negative. And the x value is positive. And a negative divided by a positive is a negative. Okay, do we have any questions there? So where would be the possible quadrants that you could have tangent equaling 4/3? Very good. Quadrant 1 and quadrant 3. And that's your answer. Do you have any questions?